Hello everyone, welcome back to the channel. In today's session, we will discuss an important topic in microcontroller programming. Lecture 6, Data Transfer Instructions and Instruction Set, Basics in the 8051 microcontroller. Today's topic of the day focuses on how data moves inside and outside the microcontroller, which is a fundamental part of any program. In this lecture, we will cover three key areas. First of all, basic data transfer instructions. We will learn how data is transferred between registers, memories, and input-output ports using instructions like MOV, MOVX, and MOVC. Okay, we have already discussed about this, the MOV instruction, MOVX. MOVX, we are using here the X term. This is for the external interfacing, external data transferring, right? And MOVC, that is for the ROM, right? ROM purposes. In the second thing, stack operations. We will understand how the stack works, including instructions like push and pop instruction, and how it is used during functions calls and data storage. Third thing, external memory access. We will see how the controller communicates with external memory using specific instructions and control signals, right? By the end of this lecture, you will understand how data flows within the microcontroller and how different instructions are used to control that flow efficiently. This knowledge is very important for writing effective and optimized programs in embedded systems. So let's get started. Right? So we will see here in the lecture 6, today's lecture, data transfer instructions, we will cover these topics basically in this lecture. Instruction set basics and types, basic data transfer, stack operations, external memory access. We will see one by one in the next slides. Now, instruction set of 8051 microcontroller, right? So instruction is a command to the microcontroller to perform a given task on a specified data. We have already discussed this thing, that is the first definition of the instruction set, right? Each instructions has two parts. We have already discussed in the previous lecture of this. Operation code, right? This operation code, we can take an example here. You can see, just think, we can take a pen here. Just see where, here, move, right? This type of syntax we can just, this is the move, right? This move, that is the operational code. Okay, this one, that is also called the opcode, right? Second thing, that is the operand, right? This one, data to be manipulated. We want to transfer data, है ना? Suppose one register is given here. This is the near with the opcode, right? Function, this one. So this operand, this is the register, is also called the operand, right? This is the destination operand. Okay? Destination operand. Right? This one. And comma, we can use here the another register or any value we can put here. This one. Right? Has 25H. This value copied, right, as it is value because we are using here the immediate addressing mode. This value copied and transfer here. Okay, this is the function of the instruction. Noted? Okay. Now we can move for the next thing, operand or data. Right? You see here, operand or data can be specified in various ways. Right? It may include, that is the 8-bit or 16-bit data, right? An internal register and memory locations, right? So we can use anything as a operand here, right? This one. Suppose we are using here the 30H. Suppose we not using the H sign here, this one, right? We can take a pointer. Here we are not using this one, H sign here. That means this is called the memory location, right? Some data is available here at this location. We copied this data and transfer here in this register. Okay? So this is the memory location thing. Right? In some instructions, the operand is implicit in instructions. Right? Okay. Now we can move for the next. The way of specifying an operand in an instruction is called addressing mode. Remember, we have already discussed about this. What is the addressing mode? This is very helpful for the selecting of the instruction which is the beneficial to the users. Right? Instruction set of 8051 microcontroller. The instruction set of 8051 is classified into 5 types. Remember, right? So first of all, data transfer instruction. This is the first. We can take just remember this thing. है ना? First way. Second way, arithmetic instructions. Right? Third way, logical instructions. Next one, bit or Boolean manipulation instructions. Remember, right? We will see one by one how to implement these instructions, right? Next thing, control transfer or branch instruction, right? These are the 5 types of the instructions. We can say the classification of the instruction. For control transfer or branch instruction, that is the conditional branch. Second thing, unconditional branch. If condition is available, that's why we can say that is called the conditional branch. If condition is not given in the instruction, that is called the unconditional branch. Okay? Next thing, this is the important part. Basically, you see here. So 5 columns available here. You see the instruction, first column. Second column, example. Third column, bytes. Okay. Fourth column, cycles. Fifth column, opcode, hexadecimal. Right. So we can use here for the programming purpose, right? Understood this thing? This is the move, right? Instruction we are using here. First the move, right? This one. We can take example you see here, right? The example is given. We can take example this one, right? This one. You see here, this is the operand, destination operand, this is the source operand, right? We are using here the register. You see instruction move, that is the op code, right? This is the register, that is the operand. Remember? So here both registers are there, destination register and source register you see here, A, comma, R0. Okay? You can remember this thing, this instruction is a one byte instruction. Okay? For the execution purpose, the one byte space is required for this. Right? This is called the one cycle. Suppose we want to execute of this instruction, the one machine cycle is required. We will see in the detail what is the purpose of machine cycle. We can represent in this ways M/C, machine cycle. Okay. So how many machine cycles is required? One machine cycle is required here for this instruction. Okay. One most important thing you see here, opcode, right? Hexadecimal, है ना? This value in the hexadecimal you remember, right? We can use also in this way, E8H. Suppose we are using this code, right? This code represent the move. Remember, we are using this way. Directly we can use, this is the user friendly, so we can put the, for the data transfer directly we can use the move. But you can also this instruction, this value, this is this value also called for this purpose. Okay, remember? Second thing you come here, this is the move or direct. Move direct. Move, that is the operational, right? This thing opcode, but this is a direct. So we want to transfer data from the memory directly, right? So you see here we are using here the location. This is the memory location, this one. Which memory? This is the RAM memory, right? The number of memories available, right? So we can choose one memory, that is the 30 location. We collect, or we can say the content of this location copied and transferred here in the accumulator register. This is the explanation of this instruction, right? For this 2 bytes instruction, this instruction is called the 2 bytes instruction. For this execution, 2 machine cycle is required. Remember, suppose we want to transfer data from the memory to register, the 2 machine cycle is required. Remember? And for this, we can use this code. Okay, this one, E530. 30 represent the location, or E5 represent the move, right? This one, E530. This is the for move direct purpose, right? Next thing, we can use the opcode also in this way. Suppose we want to use as a immediate addressing mode. Remember, right? So we can take an example here. Move R0 has 55H. Here this is the constant value. Copied this value and transfer in the register R0. Okay. Now we can say this instruction, 2 byte instruction, this one. right? For this, the machine cycle is required 1, right? Remember, for this, we can use the 7855. You can remember in this way. Suppose this value, we can take just this thing. You see, this is the constant value. Suppose constant value is given here, right? This one, this same value, right? So you can say this operational code for move immediate purpose, for the immediate addressing mode. Remember? Okay. Next thing, move for the indirect purpose. And we want to use the indirect addressing mode. You see here we can take example, move a comma at the rate r0. This at the rate point out the location, basically the value given here r0, the some value given here. We find the, this represent basically the location, this represent the location. This all term is represent the location. Suppose r0, some value is given here. Suppose this value 55 value is come here, right? r0. So we find the location 55 and copied the value in respect of this location and transfer in this register. Okay. For this, so this is the one byte instruction. You just remember this thing. And this is for the required 2 machine cycles for execution of this instruction. Okay. Okay. The opcode of this instruction is the just E6. Remember, and you see here this is the indirect addressing mode. You see this is the indirect addressing mode. You see this is the register addressing mode. Basically here the register use, also here the register use. In this way we find only the opcode in 8-bit. Remember, this is the hexadecimal things. Remember, right? For the remembering purpose, you can just remember, right? Next thing, MOVX. We are using here this term X. X is nothing but external purposes, external RAM. Noted? Okay. So we can take example here, MOVX A, right, at the rate DPTR. Okay, DPTR, that is the 16-bit register. Okay, this is the 16-bit register. In terms of, we can use here the DPL or DPH, right? We can break off this because this microcontroller only work 8-bit, and at a time only 8-bit work, but we have the 16-bit, so we can split in 2 parts of this register, DPL or DPH. Okay, this is the higher byte, this is the lower byte, we can consider, right? For this, this is the 1 byte instruction. This is finished in the 1 byte, but 2 machine cycle is required for execution of this, right? External RAM transferring data. Okay, so we can take here, this is the opcode. We can use this one, either this or this, right? So we can decide which one, and facilities available in the just a kit, number of kit available in the market. Sometimes we can put the opcode, they provide the results. Okay, the automatically, suppose this value we can take, and this value we can enter in the kit. So the just a processing, this type of processing will execute, right? Okay. Okay, now you see here the MOVC, and C, that is the code purpose, code memory, right? This one. So we can take an instruction for this MOVC A comma at the rate A plus DPTR. Last time we have seen in the detail of this previous lecture, you can see for this. Okay, this is the 1 byte instruction. What for this execution the 2 machine cycle is required. Remember, right? For this instruction we can use the opcode of this 93. Remember 93H in the hexadecimal values are given here. Okay? Okay. Now we will see here next thing the push. This is the push instruction, right? So this push instruction directly we can use in this way. The push, this is the push and 20H. That is think the location of the memory, right? You can noted this thing. This represent the location of the memory. We want to push the data, right? Suppose we have just like we can take example here. Suppose we have just this is the RAM, right? This is the RAM. Okay, so this is the just a space, memories are given here. This one, right? This one. So we can put the data here. From this location we can put data, right? For this, this is the 2 byte instruction and machine cycle also required 2 for this. We can take a data, right, and enter here and push the data here. This one, this one, this one. In this way we can put the data. Okay. In the same thing we come here. This is the pop instruction. Pop, that is the POP20H, this value. So we can out the data from here to outside. Okay, remember, from memory to another place we can transfer data. So this is the pop instruction. We can just out data from this memory. In the push instruction you enter the data in the RAM. This is the difference between the push and pop instruction. Noted? Okay. You see here, this is the opcode of this. 20 they represent the location. Okay. Or this represent the just opcode of the instruction. Okay. Now you see here, for this, okay, we can take just wait, we will see in the right. We have seen the just push instructions. Push basically we want to just data from register, right, register to stack, right? But in this case, in the pop instruction, from stack to register, right? We can say in this way, stack to register data transfer. Now we will see the exchange instructions, right? You see here the total instruction of this exchange A comma R1, right? How to exchange this thing? So suppose we have already the value A equal to 25H, right? R1 equal to 10H. Okay. Suppose we are using this instruction action to totally exchange this data. This total value come here in the register A. This value come here in the register A. After the execution of this instruction, the A equal to 1 0, R1 equal to 25H, right? For this instruction is the 1 byte instruction and execution time is 1 machine cycle, right? And the opcode, that is the C9, if we want to use as a opcode of this instruction, this is the C9, right? Next thing, exchange digit. This is basically only exchange the digit, means lower nibble will exchange. So we can consider here, suppose we have A equal to 25H, okay, at the rate R naught equal to 10H, the same value we are using here. The lower nibble, that is this thing, lower nibble, that is this thing. So this will be interchange, okay. So after execution of this, the A value is given now 20H and R naught, this one, at the rate R naught equal to 15. Okay, only change this value because we are using here the digit. Digit is nothing but lower nibble will exchange. Okay, for this 1 byte instruction and the execution time is 1 machine cycle. Okay, the opcode D6 for this instruction, right? Now we can move for the next instruction. Okay, now you see here the move, that is the move, okay, this one. Next thing, the syntax of this, the move destination and source. We have already seen this thing, है ना? Move destination or source. This is the syntax of this move instruction, right? Destination may be the register or maybe the memory. Understood? Source, the similar thing. This is the register. Memory, this may be the memory or this may be the immediate number, right? Constant value. Okay, these are the difference between the destination or source. Operation of this instruction, the copied or transfer data from source to destination. Remember, right? For example, we can take example here. Move A comma has this is the pound sign, right? 1 2H. This is the constant value. We have already discussed about this. Okay, if we are using the pound sign and give the number, any number, this number is the constant value. This constant value is copied and transferred in the destination register, right? And we can take another example here. You can see the move A comma Rn. N is nothing but n equal to 0 to 7. Right? We can put here the R naught. The content of R naught is copied and transferred in the accumulator A. That is the syntax of this. Similar thing you can see here. This is the move at the rate Ri. I is nothing but 0 or 1. Remember, in this case only R0 and R1 will use. Okay, we can take here at the rate R1, right, comma A. The content of A is copied and transfer at this point location. Okay. Next thing, move X. X denoted the external purpose. Okay. Transfer data between accumulator and external data memory. Okay. Okay. Now you can see here the move X, right? A comma at the rate Ri. Ri we can use here the R naught. Okay. The any value at this location is copied and transfer in the accumulator here. Right? This is the thing. Same thing you can put here, the content of A is copied and transfer at this location. Right? This is the actional thing. You see here we are using the move X A comma at the rate dptr. Okay. At this location we find the value and copied and transfer in the accumulator. Okay. This is the thing. Next thing you can see here, the MOVX at the rate dptr comma a. The content of A is copied and transfer at this location. This location, that is the external RAM. Okay. Okay. Now we can start this one, MOVC, right? MOVC, that is the code purposes, that is related to the ROM, right? You can see here we have already discussed in the index addressing mode, but also we will discuss here in the detail, right? MOVC A comma at the rate A plus dptr, right? You remember here you can use either dptr here or pc as you wish, you can decide, right? So that thing, the copied data at this location, right, and transfer in the accumulator, that is the indexed addressing mode, right? Operation of this you see, loads a register, this one, right, with a byte from program memory, right? This one data we can find from the program memory, that is the ROM. Example of this, move C A comma at the rate A plus dptr. This value we can find from this address and copied and transfer here, right? This is the example. Another example in the similar, only we can use here the PC in place of dptr. Okay. Okay, now we come on the push instruction, right? You see here. For the push instruction, that is the push or source, right? This one available with the source, some value, right? Here, the some location, right? You see here the increment the stack pointer, right, by 1. In this case, we can push the data in the stack, in the RAM, right, and increment the register. Stack pointer is shifted to the upper side by using the 1 increment. Transfer source content onto the stack, right? Note of this, push and pop instructions support only direct addressing mode. Okay, remember this is related to the direct addressing mode. Example you can see here, push 0E0H, right? This one. This one is the direct addressing mode we are using here, right? Push 80H. Right? Next thing, the pop instruction, right? In the pop instruction, you see here the pop destination. You remember, here we are using the source, here we are using the destination. This is the difference, push and pop. Right, operation of this pop instruction, copy data from the stack to the destination specified in the instruction and then decrement by stack pointer, right, y1. This is the difference between the push and pop. In this case, the increment the stack pointer, here the decrement the stack pointer. We can take example here, just wait. We can take here the example pop 80 and pop 0E0H. Okay. Next thing we can use here also exchange, right? Exchange a comma source, right? This source here, that is the RAM, not a RAM, this is the register and memory, right? The operation of this exchange accumulator and by variable specified in the source, right? We have already seen in the previous slides, right? Exchange a comma rn. Rn nothing but r not to r7. We can use any one here, right? Same thing you can use here, exchange a comma direct. We can put here the location also, right? And you can see here the exchange a comma at the rate ri. Okay. And also we can take this exchange this is the digit, right? Exchange lower digit, है ना, this one. Next thing you see xchd a comma at the rate ri. Okay. Okay. Now exchange lower digit of accumulator with lower digit of the memory indirectly is specified in the instruction, right? Now we come on the summary part. You see here the instruction set basics and types. Data transfer instructions, immediate register and internal memory. Data transfer instruction to access stack. Data transfer instructions to access program memory and external data memory, right? In the next class we will see, right, explore the arithmetic instructions of 8051, enabling operations like addition, subtraction, increment, decrement in embedded task, right? Some sample questions are available in this slide. You can solve these questions and provide the answer in comment box. Okay. Now the embedded systems, every instruction is a messenger and data transfer is how ideas move from thought to action one byte at a time, right? Thank you very much for listening me.